Friction, sample problem number 1. A 3.0 kilogram block of wood sits on a horizontal wooden floor. The largest horizontal force that can be applied to the block before it will start moving is 14.7 newtons. Once the block starts moving, it only takes 8.8 newtons to keep it moving at a constant velocity. Part A. Calculate the coefficient of static friction for the block and the floor. B. Determine the force of friction acting on the block if a horizontal force of 6.8 newtons east acts on the block. C. Calculate the maximum magnitude of static friction acting on the block if a 2.1 kilogram object is placed on top of it. And D. Determine the coefficient of kinetic friction. Let's start by identifying what is given in the question. We know the mass is 3.0 kilograms and F at A is 14.7 newtons. So required to find the static friction coefficient. Since the box is not moving, the net force on the block is 0. That means that the static maximum force on the block must also be 14.7 Newton acting in the opposite direction to keep the block at rest. To calculate the coefficient of static friction, we can use the equation μS equals force S max divided by force N. Also, the force of gravity must be equal to the normal force. So, solution, μS equals Fs max over Fn equals Fs max over mg, an alternate way of calculating Fn. And we know that the Fs max is 14.7 newtons and mg is 3.0 kilograms times 9.8 meters per second squared, and that gives us a value of 0.50. Notice that 1 kilogram per meter squared is 1 newton, so the units cancel. Number B. The horizontal applied force, 6.8 newtons east, is less than the maximum force of the static friction, 14.7 newtons, so the block will remain at rest. This means that the net force on the block is still 0, and the applied force must be cancelled by the static friction. So the static friction on the block must be 6.8 newtons west. Given MT is 3.0 kilograms plus 2.1 kilograms equals 5.1 kilograms. So you're asked to find Fs max. Since the materials are still in contact, μS is 0.50. To calculate the maximum force of static friction, use the equation μS equals Fs max divided by Fn. Since the total mass is now 5.1 kilograms, we can calculate the normal force using force N for normal is mass T times G. Substituting in, we get 0.50 times F.1 kilogram times 9.8 meters per second squared is 25 newtons. So the maximum magnitude of static friction acting on the block is 25 newtons. Part D. Given the mass is 3.0 kilograms and F at A is 8.8 newtons required to find the coefficient of kinetic friction. The block is moving with a constant velocity, so the net force on the block is 0. This means the kinetic friction, F at K, on the block must also be 8.8 newtons acting in the opposite direction. To find the coefficient then of kinetic friction, we can use the equation μ K is Fk divided by Fn. So once again, we'll use our alternate formula. So we will get 8.8 newtons divided by 3.0 kilograms times 9.8 meters per second squared. So μ K is 0.30. So we know the coefficient of kinetic friction is 0.30. Now, on to sample problem number 2. Check out the solution in my next video.